Question number 2. How many sulfuric acid, hydrogen sulfate molecules are there in 1 gram sulfuric acid? We know 1 mole sulfuric acid equal to 98 gram sulfuric acid. 98 gram. Why 98 gram? H2SO4 molecular mass is hydrogen 1 into 2 because there are 2 hydrogen, sulfate 32 plus oxygen 16, but there are 4 oxygen. So total 98 gram. So total 98 gram. So according to the definition of mole, if molecular mass expressed in gram unit, then that amount substance is known as 1 mole. So 1 mole sulfuric acid equal to 98 gram sulfuric acid. According to the Avogadro number, 1 mole sulfuric acid contains 6.023 10 to the power 23 number of hydrogen sulfate or sulfuric acid molecules. So here 98 gram sulfuric acid contains 6.023 10 to the power 23 number of sulfuric acid molecules. So 1 gram sulfuric acid, according to the unitary method, 1 gram sulfuric acid contains 6.023 10 to the power 23 divided by 98. So after calculation we get 6.14 10 to the power 21 number of sulfuric acid molecules. Welcome to my channel Jahangir'S Science School. Chapter 6, Concept of Mole and Chemical Counting. Question number 3. Calculate the mole of water H2O present in 5 gram water. We know 1 mole water equal to 18 gram water. So 1 mole, so 18 gram water contains 6.023 10 to the power 23 number of hydrogen molecules. So here 18 gram water equal to 1 mole of water. So 1 gram equal to unitary method 1 divided by 18 mole of water. So we have to find out the 5 mole, 5 gram. So 5 gram water equals to 1 into 5 divided by 18 mole of water. So after calculation 0.277 mole of water. Now molar volume of gas. The volume of 1 mole gaseous substance occupies is called molar volume of the gas. So the volume that 1 mole of gaseous substance occupies is called molar is called the molar volume. So remember at 0 degree Celsius and 1 atmospheric pressure is called the standard temperature and pressure is called. So 0 degree Celsius and 1 atmospheric pressure 0 degree Celsius temperature and 1 atmospheric pressure is called standard temperature and pressure, STP, standard temperature pressure. The volume of at STP, standard temperature pressure, the volume of 1 mole gas is 22.4 liter. to 22.4 liters. So remember molar volume. Molar volume means the volume that 1 mole of gas or gaseous substance occupies is called molar volume. So standard temperature pressure means at 0 degree Celsius temperature, and what atmospheric pressure is called STP, standard. At STP, the volume of 1 mole gas is 22.4 liter. So number of mole, we can find out the number of mole denoted by small n equal to mass divided by molecular mass, divided by molecular mass, or n equal to volume divided by volume of 1 mole, volume of 1 mole, or molar volume. Or we can calculate mole number by using this formula, number of atoms or molecules or ions divided by Avogadro number. So n divided by 6.023 10 to the power 23. So by using this formula we can calculate number of mole. So number of mole calculation, number of mole equals to mass divided by mass of 1 mole. So mass of 1 mole. So mass divided by mass of the substance divided by mass of 1 mole, so volume equal to volume divided by volume of 1 mole. So another technique, number of atoms or number of molecules or number of ions divided by Avogadro number. Now some mathematical problem. How many molecules are there in 1 liter carbon dioxide gas at standard temperature and pressure? So question is how many molecules are there in 1 liter of carbon dioxide gas at STP. STP means standard temperature and pressure. STP. So our question is how many molecules are there in 1 liter of carbon dioxide gas? So remember 1 mole carbon dioxide, 1 mole of carbon dioxide equal to 44 gram carbon dioxide, and it contains 6.023 10 to the power 23 number of molecules. So this is the Avogadro number, and remember the volume of 1 mole gas is 22.4 liters of carbon dioxide gas at STP. So here at STP, standard temperature pressure, 22.4 liters carbon dioxide gas contains 6.023 10 to the power 23 number of carbon dioxide molecules. carbon dioxide molecules. But we have to find out the number of molecules present in 1 liter. So at STP 1 liter of carbon dioxide gas contains 6.023 10 to the power 23 divided by 22.4 liter, because we have to find out the number of molecules are there in 1 liter at STP. So after calculation, the result is 2.69 10 power 22 number of molecules, number of carbon dioxide molecules. So look at the question. So how many molecules are there in 1 liter of carbon dioxide? Remember 1 mole carbon dioxide equal to 24 gram carbon dioxide. It contains 6.023 10 to the power 23 number of molecules. So the volume of 1 mole gas always 22.4 liters of carbon dioxide gas at STP. So at STP 22.4 liter carbon dioxide gas contains 6.023 10 to the power 23 number of molecules. So in 1 liter, by unitary method, we can calculate easily 6.023 10 to the power 23 divided by 22.4. So 2.69 10 to the power 22 number of carbon dioxide molecules in 1 liter carbon dioxide gas. Now we discuss about molar solution. At a fixed temperature and pressure, if one molecule solute is dissolved in 1 liter solution, then that solution is called molar solution of that temperature. So molar solution is denoted by capital M. 1 molar solution is the amount of solute is dissolved in 1 liter solution, then that solution is called 1 molar solution. Preparation of solution with different molarity. Mass of solute in gram unit equal to molarity of the solution, volume of solution in milliliter unit, and into molecular mass divided by 1000. So mass of solute is denoted by capital W. So W equals to S, molarity of the solution, that means concentration of the solution, S into V, volume of the solution in milliliter, into M divided by 1000. This is the formula to calculate the amount of solute required to produce different molarity solution. Now we want to prepare 250 milliliter 0.2 molar sodium chloride solution. We want to prepare 250 milliliter and 0.2 molar sodium chloride solution. We have to calculate how amount sodium chloride is required to prepare 250 milliliter of 0.2 molar sodium chloride solution. So here we know, according to the definition of molar solution, to prepare 1000 milliliter 1 molar solution of sodium chloride required 1 mole sodium chloride. We know 1 mole sodium chloride equal to 58.5 gram sodium chloride. So 58.5 gram of sodium chloride. So to prepare 1000 milliliter 1 molar solution of sodium chloride, 58.5 gram of sodium chloride is required. So we have to we want to find out the amount of sodium chloride required to prepare 250 milliliter solution. To prepare, first we have to calculate by unitary method 1 milliliter 1 molar solution of sodium chloride. So remember, to prepare 1 mole we need less amount, so 58.5 gram divided by 1000 milliliter so eto gram of sodium chloride is required. But to prepare 250 milliliter solution of 0.2 molar of, so 250 into 0.2 molar into 58.5 divided by 1000. So after calculation, so answer is 2.925 gram of sodium chloride is required. We can calculate this amount of solute, that means sodium chloride required, by using the formula alternative method. We can use direct formula. So W equals to volume into concentration, that means molarity and molecular mass of the solute divided by 1000. So here volume is 250 and molarity 0.2 molar, and molecular mass of the sodium chloride, that means solute, 58.5 gram divided by 1000. So we need 2.925 gram of sodium chloride required. Now question, how much sodium carbonate Na2CO3 is there in 2 liter 0.1 molar sodium carbonate Na2CO3 solution. Molecular mass or relative formula mass of sodium carbonate Na2CO3 equal to atomic mass of sodium is 23, but here 2 sodium, so 23 into 2. Carbon 12 and oxygen 16, there are 3 oxygen, so 16 into 3, so 106. To prepare 1000 milliliter of 1 molar solution of sodium carbonate, 106 gram of sodium carbonate is required. So 1000 milliliter equal to 1 liter, because in our question it is 2 liter. So to prepare 1 liter 1 molar solution sodium carbonate is required 106 gram. So 2 liter 0.1 molar solution, 106 into 2 into 0.1. So 21.2 gram, after calculation 21.2 gram of sodium carbonate is required to prepare that solution, 2 liter solution of 0.1 molar. Now we want to calculate the percentage composition of element in compounds. So percentage composition. So percentage composition of an element equal to atomic mass of the element, mass of the element into number of atoms, number of atoms divided by molecular mass of the compound, molecular mass of the compound into 100%. Into 100% is the formula. Say water, the molecular mass of the water, say the molecular or relative formula mass of water equal to hydrogen 1, and there are 2 plus 16, so 18. If we want to calculate the percentage composition of hydrogen atom, percentage composition of hydrogen atom equal to atomic mass. Atomic mass is 1 and number of atoms 2 divided by total molecular mass of water is 18 gram into 100%. So this is the formula. And percentage composition of oxygen atom, oxygen percentage, so 16 into 1 divided by 18 into 100%. So 88.89 percentage, and here 1.11% of hydrogen. On the other hand, 88.89 percentage of composition. So this is the technique to calculate the percentage composition of an element in compound. So remember, the percentage composition of an element equal to atomic mass of that element into number of atoms of that element into molecular mass of divided by molecular mass of the compound into 100%. Now we want to find out the percentage composition of aluminium, sulfur and oxygen in aluminum sulfate. First we have to find out the molecular mass, relative formula mass or molecular mass of aluminum sulfate, Al2SO4 3. So aluminum atomic mass is 27 into 2 plus sulfate, so sulfur 32, oxygen 16 into 4 into overall 3. So 300, after calculation 342 is the relative formula mass. So percentage composition of aluminum percentage equal to aluminum. There are so atomic mass of the element. So first atomic mass of the aluminum is 27. There are 2 aluminum, so 2, so number of atoms 2 divided by 343 into 100%. Another sulfur is percentage. So sulfur, there are 3 sulfur here. Sulfur atomic mass of the sulfur is 32. There are 3 sulfur divided by 342 into 100%. So and oxygen, percentage of oxygen sulfur, so sulfate has 4 oxygen, but overall there are power 3, so 12. So sulfur, oxygen atomic mass is 16 into 12 divided by 342 into 100%. So after calculation, aluminum is 15.78%, and sulfur is 28.07%, and oxygen 56.14%. By using this technique, we can calculate the percentage composition of any compound. So percentage composition of compound, percentage composition of an element, we can easily calculate by this technique. Now we'll discuss about percentage composition and empirical formula. So what is the empirical formula? The formula that shows the smallest ratio of the number of atoms of different elements present in a molecule is called empirical formula. So empirical formula tells the smallest ratio of the number of atoms of different element present in a molecule is called empirical formula. There are another type formula, molecular formula. Molecular formula shows the exact number of number of atoms of different element present in the molecules. But empirical formula only shows the smallest ratio of the number of atoms of different element present in a molecule is called empirical formula. How we can calculate or find out the empirical formula from percentage composition? Say percentage composition of different element are given: hydrogen 2.04%, sulfur 32.65%, oxygen 65.3%. So first we have to divide this percentage composition by its atomic mass. Say 2.04 divided by 1, so 2.04. And sulfur 32 percentage, but molecular mass is 32. So 1 and oxygen 65.30. So after calculation, 16 is the atomic mass. So 4. So empirical formula. So empirical formula is ASO. So AS2, AS1, and 4. So 2, 1, 4. So AS2, SO4. This is the empirical formula of this compound. So by using this technique, we can calculate empirical formula from percentage composition.